Hello friends, welcome to this video session. The topic that we are going to cover in this session is extraction of metals. So children, before we move ahead with our discussion of extraction of metals, we must know what is an ore. Naturally found elements or compounds in the Earth's crust are called minerals. In some places, there is a significant amount of a particular metal in the minerals, which is beneficial to extract. These minerals are called ore. An ore contains a metal in the form of its compound with other elements. So, after the mining of the ore from the ground, it must be converted into pure metal. To obtain a metal from its ore is called extraction of metal. Now children, ores are converted into free metals by a number of steps, which depend on the type of the ore used, nature of the impurities, and reactivity of the metal to be extracted. The processes involved in the extraction of metals from their ores and refining are known as metallurgy. It involves three most important steps, which are as follows. 1. Concentration of ore, also known as enrichment of ore. 2. Conversion of concentrated ore into metal. 3. Refining, that is, purification of metal. We will now discuss each of these steps one by one. Concentration of ore. As we already know, ore is an impure compound of a metal containing a large amount of sand and rocky material. The unwanted impurities like sand, rocky materials, limestone, mica, etc. present in an ore are called gangue. Before extracting the metal from an ore, it is necessary to remove these impurities. The methods used for removing gangue from ore depend on some difference in the physical properties or chemical properties of the ore and the gangue. By removing the gangue, we get the concentrated ore. That is, it will contain very high percentage of the metal. Conversion of concentrated ore into metal. For the purpose of extracting metals from the concentrated ores, we can group all the metals into following three groups. 1. Metals of high reactivity. 2. Metals of medium reactivity. 3. Metals of low reactivity. We will now discuss each of the three categories one by one. Extracting metals low in the reactive series. Metals low in the activity series are very unreactive. The oxides of these metals can be reduced to metals by heating alone. For example, cinnabar, HGS, is an ore of mercury. When it is heated in air, it is first converted into mercuric oxide, HgO. Mercuric oxide is then reduced to mercury on further heating. Similarly, copper, which is found as Cu2S in nature, can be obtained from its ore by just heating in air. Extracting metals in the middle of the reactivity series. Metals with medium reactivity. The metals in the middle of the activity series such as iron, zinc, lead, copper are moderately reactive. These are usually present as sulfides or carbonates in nature. It is easier to obtain a metal from its oxide as compared to its sulfides and carbonates. Therefore, prior to reduction, the metal sulfides and carbonates must be converted into metal oxides. The sulfide ores are converted into oxides by heating strongly in the presence of excess air. This process is known as roasting. The carbonate ores are changed into oxides by heating strongly in limited air. This process is known as calcination. The chemical reaction that takes place during roasting and calcination of zinc ores. The metal oxides are then reduced to the corresponding metals by using suitable reducing agents such as carbon. For example, when zinc oxide is heated with carbon, it is reduced to metallic zinc. Besides using carbon, coke to reduce metal oxides to metals, sometimes displacement reactions can also be used. The highly reactive metals such as sodium, calcium, aluminium, etc. are used as reducing agents, extracting metals at the top of the reactivity series, highly reactive metals. The metals high up in the reactivity series are very reactive. They cannot be obtained from their compounds by heating with carbon. For example, carbon cannot reduce the oxides of sodium, magnesium, calcium, aluminium, etc. to the respective metals. This is because these metals have more affinity for oxygen than carbon. These metals are obtained by electrolytic reduction. For example, sodium, magnesium, and calcium are obtained by the electrolysis of their molten chlorides. The metals are deposited at the cathode, the negatively charged electrode, whereas chlorine is liberated at the anode, the positively charged electrode. The reactions are: similarly, aluminium is obtained by the electrolytic reduction of aluminium oxide. So children, let us now move to the last point of this extraction process, which is refining of metals. The metals produced by various reduction processes described above are not very pure. They contain impurities, which must be removed to obtain pure metals. The most widely used method for refining impure metals is electrolytic refining. Many metals like copper, zinc, tin, nickel, silver are refined electrolytically. In this process, the impure metal is made the anode, and a thin strip of pure metal is made the cathode. A solution of the metal salt is used as an electrolyte. The apparatus is set up as shown in the diagram on screen. On passing the current through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the cathode. The soluble impurities go into the solution, whereas the insoluble impurities settle down at the bottom of the anode and are known as anode mud. Friends, in this video, we studied extraction of metals. In the next video, we will learn about corrosion and prevention from corrosion.